Hello and welcome to the lecture on this topic, time and cost control. It is the textbook chapter number 12 of the book by William Minks and Hall Johnston. The book name is Construction Job Site Management. The objectives of this topic are, so this topic introduces the following. So actually this topic contains a discussion about the use of time and cost controls during the project. So the objectives are the reasons for using time and cost controls during the project duration controls, and the use of the project schedule as a tool for monitoring and controlling the duration of the activities and the project. The appropriate scope of schedule activities, the use of sequencing in the project schedule, a realistic duration for work activities, the use of the schedule during the project for the project participants. Some more objectives are the use of schedule to solve problems during construction, the reasons for the use of cost control during the project, including the specific uses and impact of those uses, cost control methods, the relationship between productivity problems and the responsible party solution. So, introduction. The contractor must control both the duration of the project and the cost of the project, the major parameters of the project. The contractor commits to the completing the project in a specific time frame and at a finite cost. Many contractors feel that both time and cost are naturally controlled by the construction process and field personnel. So traditionally, the contractors' field personnel did their best to complete the project as quickly as possible with the minimal cost. The results of this effort during the project were unclear. It would appear as though the project would be completed on time and the project cost seemed to be within the budget. In recent years, however, the use of construction scheduling and computerized cost control accounting provides a means for monitoring the effectiveness of the controls during a project, allowing field personnel to adjust productivity factors, crew size, and subcontractor activity to bring the project to acceptable progress. Let's talk about the project duration control. So the construction project owner will always need a project completed within a specific time period, whether explicitly stated in the contract documents or not. So the owner's date for the project completion establishes a parameter and a maximum duration for the project. So the owner's completion date, however, rarely has a direct relationship to the actual amount of time needed to construct the project. This date is often based on the owner's need for the facility rather than the expected construction duration. A school project will be required to be completed in July or August, allowing time for equipment move-in so that the facility can be in operation in early September at the start of the school year. A retailer will want its facility completed in late summer to be able to stock goods and train personnel prior to the holiday retail season. So these completion dates establish a maximum construction duration, but the contractor may be able to complete the facility prior to the completion date. So the project plan involves more than just a schedule of activities. It must consider all project needs and how the solutions to those needs affect the duration of activities and the project itself. Some planning considerations include the following: activities on the project, duration of the activities, sequencing of the activities, the interrelationship of subcontractor activities or subcontract activities, the equipment requirements for the project, utilization of subcontractors, field management personnel, crew size and project staffing of craftspeople, and anticipated material dates, weather planning, anticipated lost days, weather protection, anticipation of delays, other contractors, other contracts, labor strikes, and honor-based changes. Alternative solutions to sequencing. So therefore, a careful analysis of the entire project is needed to tie activities together to form a plan and subsequent schedule. When a scheduling consultant is used, the superintendent and other field personnel must formulate the plan for the project and convey that information to the scheduling consultant. Since the scheduling depends on the study of the activities, so it will be good at this point to consider about the scope of activities. So each activity in the construction schedule must be identifiable with the following attributes. So it should be the activity should be able to be described as a separate function, such as form work for footings. It must have a labor crew with the attributable crew hours for the activity, and it must have a specific duration attached definable for the project, such as 10 working days, and it must be able to monitored by comparing planned duration with actual duration during the construction process. So a construction activity has an identifiable block of time that must be included in the construction sequence. It can contain several different steps, trades, and estimate line items. Or there could be a time restraint before further work can be done. So two typical construction activities and their components could be the following. Typical construction activities. So for example, one of the example is this: prepare and pour concrete slab. Okay, so for this, first of all, subgrade preparation is needed, and then spread and prepare the gravel base. Okay, then install embedded items, install under slab electrical, plumbing, and ductwork, set the forms, install the reinforcing steel, set the screeds, expansion joints, pour concrete, finish concrete, and typically this type of sequence of activities may take like 3 days to complete. Another example for the activity is the cure concrete slab. So it is a wet cure concrete slab, lime restraint, no relating work to be done until curing complete. So this activity may take up to 10 days, but you can see that this is more or less like a waiting activity where not much physical work is performed. However, a lot of physical work is performed in preparing and pouring the concrete slab. So the nature of the activities on the construction site may be different from activity to activity. So based on how the activities are sequenced, there can be the short time needed and inflated time created for the activity. So as an example, we can see that preparing and pouring of the concrete, the total added hour is 34 hours. So for example, for different types of sub activities under these tasks, we may be needing the time in hours, and then total will be like 34 hours. Okay, so this 34 hours is actually more than 3 days. If we take 8 hours per day as the work time, so it will be more than 3 days. However, not every activity is performed in a series. That means one activity after that another activities. Many of these activities in this case may be performed in parallel. So therefore, we can have a duration of 3 days for these types of activities. So if some of those sub activities are performed in parallel, then that 34 hours duration can be completed in 24 hours. There are certain guidelines for setting the duration of the construction activities. So for example, an overly long duration is not appropriate for monitoring an actual against project time. Assume that for example, prepare and pour concrete slab is for a 5,000 square foot concrete slab. If the concrete slab was much larger, for instance, instead of 5,000, it is 50,000 square foot, the item prepare and pour concrete slab may be too large to monitor and may be separated into 5 sections of, say, about 10,000 square foot each, and a duration of 3 working days per section using a larger crew. So then we can divide the work something like prepare and pour concrete section 1, section 2, etc. So in this case, it will be better for more accurate monitoring of the construction activities. In most construction schedules, activity duration should not be shorter than 1 day. Well, there are some certain situations such as a plant shutdown for a short term repair or for additions that must be scheduled in small increments such as hours. A guideline can be established for activity duration such as between 2 and 20 working days, but this should not totally eliminate necessary activities that are shorter or longer. So what the recommendation is that most of the activities should be between 2 and 20 working days. So a descriptive list of the items included in each activity is a good organizing tool for checklists to determine that all activities are included in the plans. Descriptions of the activities are also good references during the project to determine if the activity is complete. So some activities may resemble others in a brief description, so the full description is necessary to identify the activity and its scope. Sequence of activities. Sometimes if a task may be completed in 2 or 3 different sequences of the activities. So maybe one of the sequence may be shorter duration and can take also less cost to complete. However, one should also be careful about the quality of the tasks performed, okay, quality of the work performed as well, as usually with the decreased duration and the decreased cost, the quality also suffers. So therefore a time cost quality compromise have to be made on the project. So from the scheduling point of view, sequencing types of the activity consist of finish to start activities. It means that the second activity does not start until the first one is completed. So for example, foundation wall needs to be completed with the forms stripped prior to setting the stud wall on the foundation wall. So we will continue in the next video clip.